Okay, so we're asked to express this quadratic in this format here. So remember now, this is completing the square, isn't it? Okay, and when we complete the square, we can't really do it unless the coefficient of the x squared is 1, right? Now in this case it's 2, so we've got to do a little bit more work here. So what I'm going to need to do is look at those first two terms and actually factorize, take out a factor, so that we end up having just 1x squared. So in order to do that, you just take out whatever is in front of that x squared, which is a 2. So that will be my factor, and then I'll do square bracket, and then I'll just work out what goes in here then for just those two terms. Okay, so I'm just going to factorize those two terms there. So what do I times by 2 to get 2x squared? Of course, then it's going to be x squared, isn't it? Which is what I want. And what do I times by 2 to get 4x? Well, that's going to be 2, isn't it? 2x rather. Okay, so you'll see there, if you were to expand that bracket, you get back to those first two terms there. So I haven't done anything wrong, okay? But of course, I've got to remember to add that 5 on the end. I'm not going to factorize that 5, okay, with the 2 here. Okay, I'm just going to leave that on its own there at the end. But what you can do now is, because we've got 1x squared here, I can complete the square of this inside here. So kind of like ignore everything on the outside. Keep writing it down, keep writing the 2 there and the 5 here, but just sort of zoom in onto this square bracket and complete the square here. And remember, when completing the square, it's bracket squared. You're going to have x, and you're going to halve this, okay? So half of 2 is 1, okay? So half of plus 2 is plus 1. And remember then, you've got to take away, always take away the square of this. So if I square 1, well, it's just 1, isn't it? And then we completed the square. So close that square bracket. You can sort of zoom back out again. Remember, we've got the 2 in front of that bracket, and don't forget that plus 5 here then at the end. Okay, to sort of finish off, I've then got to sort of get rid of this square bracket times through then by that 2 again. So I've got 2x plus 1 all squared. 2 times minus 1 is minus 2, plus then 5. Okay, so times through by 2. One final step, of course, put those integers together at the end there. Minus 2 plus 5 is plus 3. Okay, and we finished. Okay, we completed the square, and we've got it in that format they want. So we could say, look, a is equal to 2, b is equal to 1, and c is equal to 3. They're all positive, aren't they? So in part b, it says that, and hence use your answer to write down the coordinates of the minimum point on the graph y equals 2x squared plus 4x. Now notice it says plus 11. Okay, so very similar quadratic, isn't it? Except we got plus 11 here, whereas before it was plus 5. So I'm going to use this to sort of help me, and of course use the complete of the square here, just sort of adapt it to get what I want here. The best way is to start off with the question that we've got. Okay, and write this in terms of the quadratic in A. So what I mean by that is, the quadratic in A is 2x squared plus 4x plus 5, yeah? Of course, now these two are not equal, right? I'm short here and I've got 5. So what I need to do, if I add on a 6 at the end, okay, then of course then these two are equal now, aren't they? Because those two will add up to 11. But what's good then is I can use my answer from part A, because remember, my 2x squared plus 4x plus 5 is equal to this. Okay, when you complete the square. So all of that there, I can replace with completed the square. And then don't forget then, I've got this plus 6 at the end. So again then, I can simplify this, okay, to be plus 9. Now straight away then I can write down what my minimum value is, okay, and I can even write down where it occurs. So minimum value is always this here, yeah? So the minimum value of y is equal to plus 9. I don't know why I'm saying minus 9, but it's plus 9, isn't it? Okay. When, of course, this bracket is 0, yeah? This is when the minimum for y occurs. To get the least of this is when this bracket is 0, because that's the lowest this bracket can be, isn't it? This bracket cannot be any lower than 0. So that's the lowest it can be, because when you square, of course, it cannot be negative. So the lowest that can be is 0, which means x plus 1 is 0, so x will be minus 1. Okay, so that's where the minimum occurs. So what we could even do, we could draw a little sketch of this here, which I like to do. So x is minus 1, y is 9, and that's where the minimum will occur there, okay? Alright, so we've got a minimum there, and we can even mark it on the graph then. X is minus 1, y is 9, okay, and we've simply got that there from the completing the square. So that's where your minimum, that's where your minimum value, which is 9, that's your y minimum value when this bracket is 0, because it's the lowest this can be. So if you get this bracket to be the lowest it can be, you get y then to be the lowest it can be, and that bracket, the lowest that bracket can be is when that bracket is 0. Okay, so then you end up, if this is 0, y will equal to 9, and when this bracket is 0, you see then x is minus 1. X is actually the opposite of that, isn't it? Okay, so make it minus 1, makes the bracket 0.